Okay, we are on the last part of the energy storage section. In this part, we are going to talk about hydrogen as a means of a storage medium. And let's talk about it, what I mean by this. So, if you look at the energy global system transition, you start at 1850 on the horizontal axis, we are going about 2150 here, about 300-year range, and here is the total percentage of total market. And if you look at it in the very early stages, we use the wood and the hay as a means of the energy, and that we call it as the solids. And then we switch to solids coal, and then we got into the nuclear power, etc. Then initially we use the whale oil for energy purposes. Eventually we found the petroleum in 1916 or so, and then we start using the oil, and we are now peaking, for example, the usage of the oil at some point between 2000 and 2050. There may be some shift in this curve because of the recent discoveries using the fracking method for the oil and the gas. So eventually this will disappear, and the expected it is going to disappear, is a matter of when. And in this plot the scenario is shown as depleted entire oil natural gas by about 2100. And the coal, of course, we already stopped using in many places, so that is not of any consequence. So the thing we are trying to do is use the natural gas right now for the power generation to replace the coal. So the usage of natural gas is going to go up. Eventually we are going to run out of the natural gas, and it becomes methane, use of the methane, which is also comes from the natural gas. Eventually in this scenario we'll end up using the hydrogen as the energy source. So if this primarily this transition should take place around 2100 2150. In this instance is primarily due to the climate change and concern about sustainability and so on. So we can see the energy we are eventually getting into using the hydrogen. Now the question is, how do you produce hydrogen? Of course, we are interested in producing hydrogen using the sustainable methods, and this is what. So the important thing is we want to have sustainable hydrogen. We, for example, produce a lot of hydrogen right now because hydrogen is used cracking the crude oil into gasoline and all that. So wherever there is refineries, we require a lot of hydrogen, and typically that hydrogen today is produced by cracking the natural gas. So that is not what we like to do. What we want to do is either use sustainable sources like biomass, or we use the wind power, which of course the electricity is used to do the electrolysis of water, or use the solar power again to do the electrolysis to produce the hydrogen. There is one other way which is also non-polluting, but there are other concerns using the nuclear power, which is quite cheap, but except we have other issues with nuclear power is the safety and what do we do with the spent fuel and all that stuff. So, but if you do that through nuclear power, we do through catalysis. Currently we are producing non-sustainable means by natural gas, which is how we produce most of the hydrogen today, and a little bit of it using the coal, using the gasification, and or we use the petroleum coke residues to gasify to produce hydrogen. But our intent is if in this context when you produce hydrogen, we are producing using these three renewable sources: biomass, wind and solar. Right now the feedstock usage in hydrogen production, which is as I said before, is the natural gas, which we use mostly, and we use oil also to produce hydrogen, and somewhat coal. And electrolysis, which is of course is the non-polluting way of producing hydrogen, is very little because the electrolysis costs quite a bit of money. So that is the reason why we talk about a little bit more about that. So most of the hydrogen now is being produced by using the natural gas. And what is the sustainable way of producing hydrogen? You have the renewable energy. One way to do is you produce heat, like for example concentrated solar power, or for example through gasification using the biomass. And from the heat you produce mechanical energy, and from mechanical energy produce electricity, and you take electrolysis and go into the hydrogen. Or you can do what is called thermolysis using the very high temperature heat to break down the water into hydrogen and oxygen, and you can produce hydrogen. Or as I said, you can use biomass, and from that you can you produce CO and H2 by doing the gasification, and from that you can do further reduction of the CO and produce hydrogen. Or you can do the what is called photolysis using quite similar to solar cell, but here you put the solar cell in water and do what is called a photolysis. We briefly talk about that. So we talked about the different production methods. One is the steam reforming, which we converts the methane in this particular case in natural gas, and the electrolysis, of course, you know, the splitting the hydrogen and oxygen, and you can do the steam electrolysis as opposed to water electrolysis to minimize the energy used. And the thermochemical water splitting is another one, and photoelectrical systems and photobiological systems, and thermal water splitting and gasification uses of heat. So these are the different production methods which you can use, and most easiest one, and which is very familiar with, is the electrolysis. So in the electrolysis, what you simply do is you use the water and split the hydrogen. In this particular case, in the anode, in the electrolyzer, you put the water and then you apply the voltage to the anode and the cathode. Again, you split the oxygen and hydrogen from the water, and of course the hydrogen is the one which we are interested in. Oxygen, we can reuse it for some other purposes. And then of course you have to put some catalyst in the water, and we typically use potassium hydroxide. That's about 30% of solution we use. The efficiency of the electrolysis can be quite high, depending upon, these are the theoretical efficiencies. You can reach about 85 to 90%, but the purity, of course, you also want the high purity hydrogen. For that to happen, you have to have high purity water. And typically when you want to do the electrolysis, you take about 50 kilowatt hours of energy. So if you, on the average, kilowatt hour energy to produce 1 kilogram of hydrogen. Now 1 kilogram of hydrogen has about the same amount of energy as 1 gallon of gasoline. So you can think of that. So that means if you take the 50 kilowatt hours of electricity to produce this through electrolysis, electricity cost typically is about 15 cents in kilowatt hour in some places in the United States. So you are talking about $7.50 just for the electricity cost to produce hydrogen. But if the electricity is very cheap, like for example a nuclear power plant, about 3 to 4 cents, then you can that only electricity cost is only about $2, then you can produce hydrogen at an economical price. So the question is now, because we use electricity being the input plus water is not that expensive. So most of the cost is involved in the electrolysis in the electricity cost. So if you can find cheap electricity, this is the best way to do that. And this is how the chemistry for the electrolysis of water is, and how much energy is needed to do this. And these, of course, you learned this in the chemistry class before. Now we look at the efficiency of how it can be produced. Like I said, the energy efficiency of electrolysis is about 65% on the commercial unit, but there are systems, the large scale systems have efficiencies close to 85%. So this is the chemical potential is about 1.23 and electrolysis potential is about 1. This is in terms of the voltage, for example. And you can use the less voltage in this particular case, then of course you get the higher efficiency. So the idea here is to reduce the electrolysis potential, and that is done using the different materials for the cathode and the anode. And suppose you couple this with PV system, and the PV system efficiency, let's say 12%. Of course, you can get it much higher than that these days. But here the calculation assumes that the total efficiency of the PV array is about 12%. And if you have 65% efficiency for a commercial unit, then total conversion efficiency is about 7.8%. But if you can improve the electrolysis efficiency to 85% and then the PV array efficiency to 15%, then you can get to about the efficiency of 15%. So the total efficiency converting the water using electricity into hydrogen is about 15%, which isn't too bad considering other systems. Now the question one would ask is there sufficient water to sustain for the world to create hydrogen? So to answer that question, here for example I talk about the global energy demand is about the 4 times 10 to the power 20 joules per year. H2 from water, you can 1 gigajoules per 90 liters of H2O. So water needed is about this many liters to create this, and oceans have this much water, and annual rainfall is this much. So essentially water needed is about 3.6 to 10 to the power of 13 liters, and of course annual rainfall is about this much. So and plenty of water is in the oceans too. But that requires a little bit more energy. But from this slide, what I want to impress upon you is that there is enough water to sustain the production of hydrogen. This is, for example, is what is the cost of hydrogen, and this is the bottom figure, bottom axis here in this figure shows the electricity cost, and it goes from up to 10 cents per kilowatt hour, and commercial system efficiencies of about 54 to 67 kilowatt hours per kilogram. This is the 67 is a little high, but theoretically you need about ideal system is about 39 kilowatt hours per kilogram. So, but 50, in fact, we have done some systems, designed some systems operated in the lab, which has about 50 kilowatt hours per kilogram. So, if there is a nuclear power plant and that produces power at 5 cents a kilowatt hour, then you can get to about $2.50 a kilogram. So, if you can reach that, or even actually if you are anywhere between in Sweden, for example, the gasoline costs about almost $5 a gallon. So if you can produce hydrogen at $5 a kilogram, and that is equivalent same amount of energy as 1 gallon of gasoline, then we are okay. But there are other benefits by using the hydrogen in terms of the emissions generated. So if you can produce hydrogen for about $5 a kilogram, then that is quite good in terms of the regular usage both in automobiles and storage and other applications. So this plot essentially gives you some idea of what it costs to generate hydrogen. And these are some of the electrolyzers. These are nominal meter cubes they produce per hour. So these are large electrolysis machines, and these are mostly made by a company in Norway. For example, this one produces about 50 nominal meter cube of hydrogen per hour. Nominal meter cube meaning at standard room temperature and room pressure. So that's quite a large production of the hydrogen, and there are other units, and there are much smaller units at 5 meter cube per hour. So there are units, except the cost is another one which you have to keep in mind. And this is an electrolyzer. which will take about 2000 kilowatts of power to produce this. So these are very, very large scale hydrogen producing units using electrolysis. So you can see that. So the another way to produce hydrogen is what is called solar thermochemical production. So you have a concentrated solar energy then you can do what is called thermolysis or thermochemical analysis, or you can do the reforming, cracking, or gasification and carbo-thermoaerobic reduction. So the using the concentrated solar energy when you produce hydrogen, and it is called the solar hydrogen, and that I think is ultimately is the way to go. One way to do that is CSP can be very useful in doing this. In this particular case, you generate very high temperatures and then you crack the water into hydrogen and oxygen, and of course that requires very high temperatures. And the way to do this is these are the concentrated solar radiation, and then you generate the heat, quite a large temperature heat. Then you send that heat into a chemical reactor and you send the water into the chemical reactor, and then you are going to split into hydrogen and oxygen. And this is what's called solar thermochemical production, and I think this makes a lot of sense when you have a very high insulation solar radiation. And another way to produce hydrogen is through biomass. In fact, this is stuff we have done it. What you do is this is called through steam gasification. So the way you want to do is you do what is called a steam gasification. So what you do, you into the gasifier, you send the biomass and you also send the steam, and then at very high temperature, of course, the gas which is come out of natural gas which comes out of that, which is called the synthesis gas, that will be CO and plus H2. Now what you do is you take the CO and of course you react it to H2O again, then these two CO and H2O then produce additional hydrogen and CO2. So essentially what you can do is you can produce a lot of hydrogen by using what's called a steam gasification. And there are other ways of doing it also. Take this synthesis gas, either you produce hydrogen or you can produce diesel, methanol and DME fuels. But here our interest is to produce the hydrogen, and this is one way to do this, and this is actually not a difficult one to do is, and one of my students built a reactor, biomass gasifier using the steam and the biomass. So another last one we're going to talk about in the storage is the thermal energy storage, and here what you do is we use chemicals and we look at the phase change. So we do the heating of a liquid or a solid which does not melt or otherwise change state during the heating. And for example, if you take the salt which can be heated, when you heat up the salt it will become a liquid, and when you take the heat out it becomes the solid. We use that process, a phase change process, as a means of storing the energy. So it of course it depends upon the temperature of storage temperature we are trying to use, and there is in fact when you learn the CSP part of this course, hopefully they have talked about the thermal energy storage and various ways of this. One way of doing it is through a chemical or thermal storing the temperature, or you can do the thermochemical way of storing the energy. So these are different paths you can take, and this is most often is what is used today is the molten salt. So thank you. So I hope that although these are only introduction to the subject, so hopefully you have learned something about photovoltaics and the storage of energy, which are both essential for the renewable energy technology. Thank you.